Okay, this is just a lesson to just consolidate your understanding of FNet when you're using Newton's second law. So the next few slides are just some examples to show you different ways you can get questioned. But the important thing is always to remember that FNet is not just the applied force or just the frictional force, it's the sum. And sometimes though the applied force can be the only force acting on the object, and the frictional force can be the only force acting on the object, but then that will be the net force. But if there's more than one force acting on the object, you first have to solve for the net forces. So this is just showing an object where the forces are acting horizontally. You've got an applied force and a frictional force. Remember to take into account the different directions when you work out the net force. Okay, this is now showing an object moving vertically. So the applied force can sometimes be a tension force because it's a cable pulling up an object. Remember, when you have objects moving vertically, then you always have weight acting down as one of your forces. So in this case, we've made up the positive direction, so therefore the weight, Fg, has to be negative in the equation for Fnet. Okay, because we've got acceleration in the Newton Two formula, that you can be expected to use your equations of motion to calculate the acceleration of the object if you're given information about its initial velocity, its final velocity, or the time, or you're given the displacement. You can use any of those variables then to calculate the acceleration, and then if you know the mass of the object, you can calculate the net force acting on the object. Okay, so this is just an example. You have a 5 kg mass being pulled along by a 45 Newton applied force, and you don't know what the frictional force is, but you're told that it accelerates from rest to a final velocity of 20 meters per second in 10 seconds. So first work out what the acceleration is. You can then substitute that into the FNet formula to work out what the net force acting on the object. That net force then is the sum of the applied plus the frictional. You know the applied, so you can substitute that value and then solve for the frictional force. This is just a variation of the previous one where you were given the coefficient of kinetic friction. So you can use that to calculate the frictional force acting on the object. You can then work out the net force acting on the object. Once you know the net force, then you can calculate the acceleration of the object. I have left out the direction. Remember, if it asks for the magnitude, you don't have to put in the direction. But if it just asks for the acceleration, or if you're solving for the net force or any force, they're vectors, so you must put in the direction. I haven't done a complete example here, but just remember, if the applied force is at an angle, then you only use the horizontal component to work out the net force of the object, because it's only the object's moving horizontally, so that is the only component that is influencing its motion, not the full applied force. Vertically, the forces are equal to 0, so you don't have an acceleration because Fnet is 0 vertically. You only have an acceleration horizontally.